This is Chris Hines of Boral Stone. I'm the development and technical representative, and assisting me today is Jeff Tu, who's our director of technical and training. We're going to deliver some material today for you on drain and dry lath and flex and dry tape. Marketing great products that solve problems and provide peace of mind is easy, right? Not really. We're in a world of changing materials and changing building styles, and as a general result, builders and contractors take a while to make changes in the materials that they're confident in. So today, we hope to expose you to some areas where you might choose to make some product decisions that can help you reduce risk and improve your wall performance. And while we're going to talk about two of our specific products, the way that we're going to talk to you about them today is to bring up a couple of relative performance topics. We'll talk specifically about wall performance, and then in part two, we'll talk a little bit about some cracking risk in stucco and stone installations. So in part one, wall performance, we're going to dig a little bit into the building evolution and what some refer to as the reduction in our room for error. Specifically, what we're talking about here is moisture in walls when incidental water gets in, and how that's been impacted by changes in insulation and air barriers and the use of low capacity materials. And then we'll switch a little bit to the outside of the wall, and we'll talk about some changes in the evolution of cladding and the water resistant barriers and different strategies that are used to address incidental water in cladding systems. On today's call, most likely, we'll have folks from inside North America somewhere. But the point of this slide, this is the climate map from the building codes, and it shows you the 7 common climates in the US. Each of them will have specific conditions that either create a harshness for you in wall performance or potentially provide some forgiveness. And so my point here is you'll have to apply the specific climate to your product selection, and just want you to know that one solution may not fit all. So I'm going to have to limit today's conversation to a period of time, let's call it the 70 to 100 years. I haven't been around for all of it, but most of my working career has been dealing with building products and construction in general. Today we're going to focus on those walls built of wood products, and mostly residential, although the concepts we talk about today can apply to many commercial walls as well. So let's look at some of the images here on screen, and I'll bring my laser up here to help focus your eyes. But the system here on the left, this is your traditional framed true wood system. We've got solid, probably oak framing in here. There's wood lath and plaster on this particular job. And in this building system, if you were to have some incidental water, the way we built back then, there would be so much heat escape through this wall system that the walls are able to dry. And even better, the materials themselves, actual wood, does a pretty decent job of absorbing, redistributing, and then drying moisture. Then comes the need to conserve energy. You pick what year you want to look at, but additions and increases in insulation kind of took away that heat loss through the wall system, that drying potential, if you will, the room for error that we're talking about. Here we've got an image of something that's way more common now. This is a frame system. It has insulation in the stud cavity, and now we've added a processed sheathing product on the outside. In this particular case, it's probably oriented strand board. There are still solid studs in there. But the reason I bring this up is because the addition of this process sheathing, if you will, takes away a little more of our room for error. These highly processed products, plywood and OSB, cannot manage moisture as well as those timbers that we referred to just a moment ago. They're more susceptible. And so we need to figure out a way to give them back some room for error. As we move further to the right, net zero homes, attempts to meet energy code have evolved into wall systems that include very thick insulation, sometimes double framed walls, sometimes large amounts of foam or mineral fiber insulation on the outside, a bit of a moving target. And further to the right, you may end up with a similar system where they're actually including furring strips and some type of drainage plane on the outside. There, of course, have been additions of air barriers. You know, an air leakage in the old days might have helped you dry a wall a little bit, or it might have created some cold spots that actually increase risk. And so, you know, air barriers and minimizing air leakage is a good thing. Another great step in energy efficiency, kind of the next thing that goes after insulation. But again, it helps remove that room for error we're talking about. And we've talked about those low capacity materials. On the far right here, this is just an evolution, even in the adhered veneer system. They have come up with liquid weight bearing air and water barriers, as you see in that picture. Loss through framing members, the building code is now requiring in many jurisdictions that insulation be added on the outside of framing to help deal with that. Looking at this image on the far right on the bottom, this is a concept I'd really like you to take away today, because this is where I think things are going in all cladding systems: drained and ventilated systems. The concept is that you provide an air gap cladding. This allows for drainage of liquid water out of the bottom. That all makes sense. And then if you detail it properly, you provide an air inlet at the bottom, and through convection, that air can rise through the top, pick up any moisture in that cavity, and then exit out the top. This drying that occurs helps both the cladding, helps it dry out faster, but it also helps from a standpoint of water penetration. So for example, wind is attempting to push water through this wall system. Having this ventilated space there really takes the gusto out of the wind pressure attempting to bypass your concealed weather barrier, your WRB, house wrap, or whatever it is that you're using. Guess what? Changes in the weather barriers as well. So I'm going to use the term WRB for the rest of today's presentation. It means water resistive barrier, but this is really the concealed weather barrier that does the lion's share of the work in keeping water out of buildings today. In the beginning, standard building paper, or commonly known felt products, there's an ASTM standard that those meet. Commercial house wrap products came to market shortly after that, because that enabled an installer to cover a much larger space with a taller roll. And the idea then was that they could fine tune the vapor permeance of the material to help moisture escape from a building, help it dry out from construction moisture, or remove moisture vapor that's created by the inhabitants inside. The house wrap products were built in a way to let that vapor escape. The next evolution there is, how do you make that house wrap drain even a little bit better? And so there's been some innovations in that world as well. This image here is a crinkled house wrap, sort of an accordion shape. You imagine that this goes up as your first layer. You put a second layer over top, and you've got a larger drainage cavity. Same kind of concept with this product. They've added some plastic dots, which causes standoff. Same thing, we're trying to create a physical airspace between the cladding system and the primary water resistive barrier, or WRB. They're specifically talking about a WRB. Before we do, let's talk about some additional changes that we're dealing with regarding the concealed weather barriers. These are also called water resistive barriers. We often use the acronym WRB, and I'll use that for most of today's presentation. Back in that 70 to 100 year time frame, the WRB, or the concealed weather barrier, was a typical building paper. Today we might call that a D226 type felt. And nobody really wants to put up a 3-foot roll at a time, so it was logical that the next evolution would be to these house wrap products, larger rolls that cover more. And in fact, they could even fine tune the house wrap so that they have the ability to allow moisture vapor to travel out of the building and escape when it's trying to get out and help eliminate risk. That evolution led to better draining types of house wraps. For example, down here on the left, we've got an example of a crinkled stucco wrap, where the crinkles in this paper create a larger airspace. Next to that, a version that plastic dots are applied to the building paper or house wrap to create a bit of a standoff, a little larger drainage gap. And then there are those who actually include fibers, which enhance the drainage of standard house wrap. Of course, if you put plastic foams up, most of the codes allow you to tape the foam, and that can be your water resistant barrier. There has been this evolution again on liquid applied water resistant barriers, and then the evolution to the combination air and water barrier. Some other considerations for water resistant barriers. Did you know that when you take a water resistant barrier to a laboratory to have it evaluated for its performance, that the tests that they run on that product are done without any kind of fastener holes or damage that would really happen in the field? And that information about those specific water resistant barriers is often used in the computer models that designers are using to forecast the performance of their wall system. Large scale testing is certainly more representative. What we're also running into is that fastening of WRBs, over fastening, is fairly common. Anybody who has seen an installer with a pneumatic fastener gun in their hand knows exactly what I'm talking about. And it's kind of no surprise that there's a new focus on these fastener penetrations. There's articles written about it. There are claims being made about self-sealing properties on some of these materials. And so I ask you, does it really matter? Do these fastener penetrations through the primary water resistant barrier, do they matter? And my answer to you is it depends. Have you provided any drainage? Have you provided ventilation? And are you using an inexpensive WRB, or did you select a high quality WRB? I'm going to give you a bit of a graphic example here. What we're looking at is roughly a 10-foot wide by 9-foot tall wall example. And the circles that you see there represent the fasteners that an installer would use to tack that primary water resistant barrier to the wall. And for this example, we've placed those fasteners roughly 12 inches on center. It's approximate, and we're not really adding a bunch of extra fasteners for lap joints, but this is pretty close to what you'd see in the field. Okay, so this is the primary defense against water, the concealed weather barrier. If I advance the slide one time, what you're looking at now is the second, or the required layer, sacrificial layer of WR being added on top of that first one. So we'll view this slide as the first set of extra fastener holes. These penetrations are about it's the same spacing as the first layer. Now I've clicked again. This is a conscientious builder, installer who has added some type of drainage medium or provision to create a gap, and it requires fasteners. Imagine furring strips or a drainage mat of some sort being added and stapled and or nailed in a similar fashion to the previous layers of WRB. And those blue dots would represent that drainage medium. You can't install an adhered veneer system over a drainage medium, so this next click is the addition of lath. In this example, you see the X's are representing those lath fasteners at their code minimum spacing. As you can see, the picture's getting fairly busy. So here's a picture in real life. A fastener cluster at the seam there, and it's really no wonder why there's attention to fastener penetrations. Why? So I ask, what's a wall really need today? These are my opinions here. What I believe is that we lack details that can get all the way to the installer, and the installer can be trained on those. So the designer's concept and method they want this built gets all the way to the installer. The installer understands why they're doing all the steps that they're doing, which leads to you have to have care and attention when dealing with these installation details. I can't overstate the importance of flashing. The biggest area to spend time is where two trades meet. These are often where we see battles over jurisdiction, if you will, for who's responsible for the flashing. And if it's not there and I install over it, is it still my fault? Drainage in walls right now is pretty much a code requirement. If you look in the building code, you'll find language, albeit fairly vague, that says, and provide a means for drainage for any water that gets in the wall. There are code proposals underway being discussed and debated that are going to make this very clear in the future, but I would suspect you can anticipate drainage will be a clearer code requirement in the future. Adding drying potential back into the wall to address all of those issues we talked about in the beginning, where that drying potential has been taken away over the years. And why wouldn't you take any opportunity you can to reduce the number of holes you're putting in your primary defense, that concealed water resistant barrier? And if you're putting up a stucco or stone system, why not eliminate the risk of lath, rust, and corrosion at the same time? So now I'll introduce you to drain and dry lath. This is really a superior lath with a best-in-class rain screen. You don't have to read the details on the screen. I'm happy to share this information with you, but first focus on the photo on the top right. This is an installation underway with some scratch coat being applied to it. The product is two materials in one. It's a dimpled vapor barrier rain screen material that has a fiberglass lath already attached to it, so that an installer can now roll this material out in one step, eliminate the need for a second layer of water resistive barrier. So that's one layer of fasteners gone. The rain screen and lath are installed with one set of fasteners. And to help avoid excess fasteners, if you look at the image, you will see that there are clusters of fibers that are tighter together every 6 inches up the wall, which helps the installer locate the minimum number of fasteners to attach this material to the wall. Of course, it comes in a roll that is 46 feet long and provides 150 square foot coverage per roll. The lath overlaps 1.5 to 2 inches so that you can do your lap joints. And it is extremely light, easy to move around the job. And for anyone that has had the experience of cutting metal lath, this material is extremely easy to cut, and you will not require band-aids when you're done. One of the advantages I'll focus on here, and we'll come back to that in just a moment, is this opportunity to drain water and provide the ventilation drying feature that we're trying to recommend for you today. I'm going to stop for a second and talk about solar vapor drive, and I need to credit, and because I can't remember the exact contributor, I'm going to say the country of Canada for this graphic. And if you notice the spelling of vapor, you'll know that's where this came from. But I'm going to introduce you to a relatively new concept, solar-driven vapor. What is it exactly? I'm not going to spend a lot of time on it, but here's the way it works. Starts with an absorptive cladding, whether it's brick, stucco, stone. The rain event happens, and this absorptive cladding takes on some water, liquid water. The sun comes out and heats that veneer up, and the liquid water turns to vapor. Vapor's tendency then is to move towards a lower area of moisture vapor. So in this case, let's imagine that this is an example in Louisiana. It's very hot, rain event happens. The sun comes out, starts driving the liquid into vapor. The vapor is now headed toward the interior of the space because that's an air-conditioned space, and it's drier because of the air conditioning. The vapor is going to try to go that way. The risk is that a dew point temperature might be reached during this travel through the wall system. So what do you do about that? A ventilated cladding. It's the belt and suspenders approach to deal with pretty much anything you're running up against from the standpoint of water in liquid or vapor form. So water gets into the system around a failed caulk joint or something, there is drainage right to the bottom. You design it correctly, there is ventilation drying that eliminates any remaining moisture. The cladding itself can dry faster, spending less time saturated, less risk of freeze-thaw damage. If you had condensation from interior moisture headed out through this wall, again, ventilation can help remove that. And then your defense against solar-driven moisture is really the combination of the ventilation plus the fact that the drain and dry lath product is a vapor barrier. It minimizes any of that moisture vapor trying to get into that interior space. How do you make it easy to drain and ventilate? We've provided some accessories with drain and dry lath, a topside ventilation trim that has a bug mesh attached to it. This provides an easy way for you to provide the exit path for that ventilation. And at the bottom of the wall, you have a weep screed starter strip that helps drain liquid water, and it acts as your input for ventilation air. Nobody wants to leave a gap in their wall system and then allow a bunch of insects to get in there. So we also offer a bug mesh. This bug mesh comes with a pressure sensitive adhesive already on it. You can pull the release tape and stick the bug mesh on your starter strip, or if you wanted to create a colored coil aluminum version of the topside ventilation trim, you could add our bug mesh to that and provide the ventilation. Now let's go back to the graphic for a minute. What I'd like to compare here is drain and dry lath on the left. Minimum number of fasteners, 6 inches vertical, 16 inches horizontal. We eliminated all the fasteners that were in the second layer of WRB, and we combined the fasteners to attach the rain screen and lath in one step. The drain and dry example has reduced the fasteners, has provided drainage and ventilation drying. And again, the picture on the right is the more traditional system. So we haven't gotten too deep into drain and dry lath, an introduction and a why. Where would you get more information? We've got a website, www.drainanddrylath.com. You can certainly reach out to your Boral salesperson, and we've got a technical hotline for more information as well. With that, I would like to pause for just a moment and ask Jeff if any questions have come in on drain and dry in the chat line that we could handle at this time.
Yeah, Chris, we had one just come in that asked if drain and dry could be used in a wainscot application underneath fiber cement siding up above as kind of the wainscot application to grade for the stone?
So there's a lot in that question. Absolutely, drain and dry could be used for wainscot application with fiber cement above. In wainscot applications, drainage in most climates is probably all you're going to need as opposed to drainage and ventilation, but you could certainly include ventilation also. At the end of your question, you said down to grade. Unfortunately, we can't claim that drain and dry lath eliminates the need for clearance from grade. In a grade application to earth, you'd require a 4-inch clearance, and if it's down to a paved surface, we'd be looking at a 2-inch clearance. Were there any additional questions, Jeff?
Not at this time. Thanks.
Okay. All right, so now I'm going to head into part 2, and we're going to start with cracking and crack mitigation for stone and stucco. You've probably all seen in real life situations just like those on the screen. Building movement and brittle finishes. What really are those common causes of cracking in stucco and stone? Differential movement for sure. Materials move at different rates. When you put them together, they're going to move differently and something has to give. The greatest example I can put in your mind is if you were to look at vinyl siding, for example, vinyl windows, those types of materials expand and contract quite a bit compared to masonry materials, for example, or even wood. Thermal cycling, again, something that changes temperature may have a tendency to grow or shrink short term. Shrinkage, masonry products, mortar can shrink. That's just what happens. And that shrinkage can lead to cracking. Changes in moisture content. That could be in the masonry materials or it could be in the supporting substrate. For example, if you had changes in a moisture level on an OSB sheathing, for example, swelling is likely to occur. You're likely to see some cracking. Substrate movement. This is really the obvious one. Whether it's settling or some other substrate movement that can lead to cracking. Of course, wind load can deflect studs and lead to some cracking. We attempt to design wall systems so that they can tolerate deflection or limit deflection. On the right is the table from the building code that basically says what the allowable deflection is of framing depending on what type of finish you're using. We've used stone as falling in the H/360 category. In some jurisdictions, you may see it as low as H/240. And then the last item is improper installation. We do see folks that don't properly overlap lath, don't fasten it properly, don't hit framing. And of course, all of those things could lead to cracking as well. So let's talk about a couple high-risk areas. If you're going to focus your attention somewhere, this would be the areas to look. Windows. Window companies are actually starting to void your window warranty if you don't leave a gap or create a soft joint around their window products. The condition is known as masonry bind. Essentially, what's happening, if you go back to my reference of a vinyl window, the vinyl window is trying to expand. The masonry is restricting it from expanding, and those two forces fight, bad things happen. So the other area would be doors. Doors add an additional risk because they open and close. You've got an impact vibration going on there. Transitions to different substrates. As an example in the bottom right, we're talking about an adhered veneer stone system which bridges the joint between foundation and framing. This is an example of two materials that have different properties, perform differently. You could potentially anticipate cracking occurring here. This is still a detail that's offered in the NCMA installation guide. And quite honestly, we don't see a ton of cracking here, but this is a good example of what you're looking for when you transition between materials. And then lastly, material transitions on the cladding itself. Are you transitioning from stone to trim, from stone to fiber cement siding, as the question was asked earlier, or a band board or something like that? So what's the solution? The solution is you need to isolate and absorb that movement with what's generically referred to as a soft joint. So who's asking what's a soft joint? This particular graphic is from the Northwest Wall and Ceiling Bureau. This is a stucco example. And you see a storefront window. And what we're focusing on here is at the bottom, you've got a three-piece casing bead, backer rod, and sealant joint. It's a little tough to see it in this example. So let's look at a better one. This is the example of a manufactured stone against a window jamb. This detail is shown in the NCMA installation guide for manufactured stone. And this, we can spend a little bit more time understanding the components. We call this a three-piece soft joint. I have begun to call it a four-piece joint. Here's why. Here's casing bead. The purpose of the casing bead in a stucco system or stone is simply to create that nice, straight, smooth surface by which you can form this joint against, and to create the width of this gap here. Casing bead shown here in the bottom left. Call that piece number one. Well, it has to be installed with nails. So that's why I'm calling it four-piece, because we just spent a whole bunch of time focusing on nail penetrations. And if I'm going to use this option, all these fasteners are coming in right next to my window. I don't know if I want to do that. The circle here is representing backer rod. This is really nothing more than foam rope. And the purpose of this material is to create a bit of a bond break here. You may or may not be able to see the shape of the sealant or caulk in this image, but it's hourglass shaped, and it's only bonded on this side to the casing bead and on this side to the window. That's the way these materials are meant to work. The hourglass shape, when the expansion or contraction happens, the material can stretch and then return to its original position. What happens if you were to remove the backer rod from this and fill that joint completely with sealant, it would be bonded on multiple sides, and then the material will eventually destroy itself because it's trying to move and it's restricted. All right, there have been some innovations to take some steps out of that four-piece system I just showed you. These innovations involve adding the backer rod to the casing bead so that you don't have to do that as a separate step. And I understand this is a pretty cool option. But what we're finding is more common is that one of two things would happen. One, mortar is run directly against the window frame. This provides that condition of potentially voiding a window warranty. And when that window does expand and the masonry attempts to bind it, one will win, the masonry will crack or the window does. The other thing we see is that folks would just go ahead and fill it with caulk. And unfortunately, that's not the best aesthetic that can be created with manufactured stone. Over here, I pulled one photo, one paragraph from a home inspector's report. And he calls out the fact that around this window, there isn't that three-piece backer rod and sealant joint to absorb the movement we're talking about. And I absolutely agree. But can you imagine attempting to wrap that geometric window with a rigid plastic or plastic or metal casing bead to create that soft joint? Would work okay on the sides, maybe the bottom, but not so good on that round top. So let me introduce you to a solution that works. This is Flex-N-Dry Tape. This is your expanding foam soft joint solution that goes in one step instead of four. Let's look a little bit more into this. Again, I don't ask you to read all this stuff on the screen. This is from one of our pieces of literature. I'm happy to give you the highlights. But the material comes on a roll. You install it in the joint, and then it expands to fill the joint. And the tape is saturated with materials to give it properties to keep wind-driven rain out, defend against UV, and the material provides a nice, crisp, clean look in the end. You don't need someone with an artistic caulk gun, okay? So here we're looking at your standard caulk joint versus a nice, crisp, clean flex and dry joint. Let's dig in a little bit deeper. The material, as I said, expands. As it comes off this roll, it can expand as much as 1.75 inches. We don't want it to expand that much, but we need that kind of energy in the tape to keep it in the joint and keep the weather on. So the application range for this product is 3/8 to 5/8 of an inch. That's the gap you're trying to fill. If your gap is larger than 5/8, you run the risk that the material would expand too much, and then it has less ability to defend against wind-driven rain and UV. Here we just show next to a ruler, you can see the thickness as it comes off the roll all the way up to its full expansion. Okay, let's talk about how it goes in a little more detail. So the picture on the left, we've got a gap we've created here. We put in a piece of scrap lumber, we installed the stone, we grouted the joints, everything cured, we pulled the spacer at a time when the mortar has not bonded to it, and spent a few seconds there with a joining tool just to clean up the joint while things cure. Here we've gone back and installed the flex and dry tape in its full expansion. This example is black. We have black and gray materials, but this one shows a very crisp line against a white window. The window actually looks very crisp with this black perimeter surrounding it. There are actually a couple of ways we can install the product, depending on what type of stone texture you're installing. Method one, probably the easiest. You would simply pull the material, the flex and dry tape off the roll, remove the release tape, which exposes the adhesive, and then stick it to the side of the window jamb. It will immediately begin to expand, and depending on the temperature outside, it may take a few minutes. And then you can begin to install your stones and press them, is what we're showing here. Press it into the expanded tape and bring the tape back to that 3 to 5/8 inch range. Method two would be this method we've shown a couple of images where you put that scrap board in just to maintain your space, install and grout your stone system, and then come back after the fact, install the tape into the gap you've created, pressing that adhesive side against the window jamb, and then letting the material expand over to the stone. This is kind of what method method one looks like in a close-up. You can see up here, the tape has expanded to near its full thickness, but down here as the installer presses the stones into place, you can see that the tape just forms beautifully against that irregular edge of the stone. In the method two, as a close-up, here's our spacer. We just use scrap plywood. After you remove the plywood, you want to make sure if you have any weird blobs of mortar in there that you tool those, and then you can install into the prepared gap. What I've done here is we've taken a video that's, I don't know, 7 to 9 minutes or so, and we've condensed it into about 15 seconds. But what you're going to want to watch is right here. This is tape that's been installed, and it's probably about 25% expanded by the time I hit play here. But if you just focus there, hopefully this will work. So you can see that the tape does a great job of sealing the edge of that stone. Imagine how much caulk you would have had to apply to that surface that would be oozing up onto the face of the stone to get that same kind of seal. So in summary, why would you even consider using flex and dry tape? Well, the number one thing, which I would certainly die on the hill saying, is that nobody likes caulk. Nobody likes to do it. Nobody likes the look. And in fact, I'd be maybe out on a limb to say most installers don't understand how caulk works, that hourglass shape and the requirement for baccarat and so on. And when you install it improperly, it fails. The casing bead used in the traditional soft joint adds more fasteners at that critical near window location. Most caulk and sealant products have limitations on temperature of 40 degrees or above. Flex and dry, although it would take longer to expand in cold conditions, has no temperature limitations. And if you fail to account for movement, you're going to have cracks and you potentially could be voiding your warranty on your fenestration products. Again, you want more information about Flex and Dry, we're happy to give it to you, and you can go to the flexanddry.com website. You could contact your Boral salesperson, or again, that same technical hotline. And with that, I'd ask if there's any questions, and we'll see what Jeff's got from the chat box.
Sounds great, Chris. We have a few that came in on drain and dry, and also a few sitting here on flex and dry. So let's go ahead and wrap up the drain and dry questions really quick, if you don't mind.
Yes.
I'll ask you the question, and then I'm going to ask the second question and answer the second question while you get ready for the first one. The question for you is, can drain and dry lath be used behind cement board to create an airspace? The other question around drain and dry that we got was kind of what's the cost savings or the labor savings that we see with drain and dry, and that's going to vary depending on the size of the job, where it's being used. Obviously, smaller jobs, there's less time to be made up, but on most jobs that range from 150 square feet on up, you can save about half the time over a traditional install when you need to make 2 passes versus 1. And then also in working with a fiberglass lath that you can cut with a utility knife or scissors, you can move a lot faster than when you're trying to be careful and cut a metal lath. So time savings about half the time, and that typically will offset your cost for the material. So Chris, the question again was, can you use drain and dry behind a cement board application?
That's a great question. And in fact, I'm going to use one of Jeff's explanations of what what drain and dry is like when you're done putting the scratch coat on it. Jeff describes during his training that essentially what you're creating is a field manufactured cement board. By putting a scratch coat on top of drain and dry lath, it now becomes a reinforced cement board, essentially, that you created. So to answer your question, could you put drain and dry lath behind a cement board? You could, but unfortunately, if you did that, I think you'd be wasting the component of the glass lath, because you wouldn't be installing a scratch coat, and you'd be better just choosing a straight up rain screen only material to go behind your cement board, and then doing a direct application of stone to cement board with a polymer modified mortar.
Great, thank you, Chris. So moving on to some flex and dry questions. There's some great questions here. The first one, as you described method 1, installing first and then pressing your stone into the tape as it expands. From the time that you put the tape up, is there a time limit before you need to press the stones into the tape?
There is no time limit. You could essentially apply that material and leave for the night and come back and finish the next day if you wanted to.
All right, moving on. How does flex and dry tape hold up to pressure washing, and can it be painted?
Pressure washing manufactured stone, stucco, and including flex and dry do increase your chances of damage. It really depends on the pressure you're using, but I can envision a situation where you could damage flex and dry with a power washer. But we would highly advise that using the kind of pressure that would damage the flex and dry, you shouldn't be doing that on stone anyway.
Great. And then as far as painting, you touch on that?
You can paint it. The product can be painted with any acrylic-based paint, or it could be top coated with sealant if you choose to do that.
Great. I'll take this next one. The question was, what are you using to create the gap, the 5/8 gap, the 3/8 to 5/8 gap between the dissimilar material and the stone? And typically contractors will use a piece of foam that they've ripped down to that size, or some of the scrap wood that might be laying around on a job site, or some are even making pieces that they can reuse from time to time on these jobs to create that space. The trick is that after you have installed the stone and done your grouting, before that grout fully hardens, you want to pull those pieces out so that you don't damage the grout joint after it is set. So the next question for you, Chris, is what is the life expectancy of flex and dry tape?
So I can tell you that when flex and dry tape was created some 26 years ago, they were having very similar questions right from the start. This product and this technology was created in Europe. And what they did at that time was they built an assembly that would sit outside facing the sun at a 45-degree angle, so a very extreme sun and weather exposure. The flex and dry was placed between aluminum bars. And what they do is they take the test panel down every single year and run it through a water penetration test. And for 26 straight years, it has passed the test and achieved a great result. So that's 26 years running in an extremely harsh environment since the product's innovation. So I hope that answers your question.
Great, thank you. We've got two similar questions, so I'm going to go ahead and combine them. With flex and dry tape, will I have any issues with my code officials if I switch to flex and dry? And does flex and dry meet ASTM requirements for sealing around the soft joint versus using backer rod and sealant?
So in the world of innovation, the building code often gives you a path to do a test and show that your product is equivalent to whatever is listed in the code. And in this case, it is a wind-driven rain test that is required to prove the alternative solution works. We've conducted that test with Hurricane Katrina type weather conditions and performed wonderfully. That test report is actually offered on the Flex and Dry website. And we also have installation instructions. And I would suggest that you combine the installation instructions with that test report and provide that to your code official as early in the process as you can. My advice is always, it's better to talk to those guys before they show up on a project, take their stand, and then you have to talk them off the ledge.
Great. Chris, I think that handles the questions we have so far, unless any other ones come in here in the next few minutes.
I believe that in the chat box, we are going to include both the contact information for Jeff and myself. If after the presentation you come up with additional questions, or after spending some time on the two websites, you have additional questions, we'd be happy to help you.
Great. Thank you, Chris. We had one more question come in. Can flex and dry tape be used for brick expansion joints?
So flex and dry tape can be used in other applications, commonly used in brick control joints and things. Basically, our requirement is gap size and that it be a vertical application.
And so I think just to add on to that, it would work for material transitions between stone, stucco, wood, brick, any of those, as long as it stays within that 3/8 to 5/8 range.
Yes.
Good, thank you.
All right, so that concludes the prepared presentation and the Q&A session.